Welcome to one and all once again on this third video of the alkyl halide. So remaining point is chemical properties. So chemical property is depending upon the carbon and halogen present on that structure of alkyl halide. So because of that halogen being of greater electronegativity than the carbon atom. So CX bond is slightly polarized, so it forms the partial positive and partial negative charge on carbon and halogen respectively, that is delta plus and delta minus. Thus the reagents which is more basic in nature, more electronegative in nature than that of halogen atom, then easily attack on the positively charged carbon atom and ejection of the halide ion takes place. So such base are nucleophile capable of donating the electron pair, and thus the nucleophilic substitution reactions are characteristic for these alkyl halides. Means what is happen, carbon is electropositive, so more electronegative reagent is get easily attack on that particularly carbon atom. For example, in the following reaction, the stronger nucleophile OH displaces the weaker nucleophile X front the carbon nucleus of the alkyl halide. So there is the mechanism gives idea about, that is nucleophile OH minus more electronegative attack on a positively charged carbon atom, and the product is formed which is contain OH group and leaving of the X group is takes, that is leaving of halide takes. Then types of the nucleophilic reactions. So depending upon the chemical property, there are mechanisms having types, that is reaction mechanisms, that the above nucleophilic reactions are of two types, SN1 and SN2. SN2 reaction are those in which the attack of the nucleophile and the ejection of the halide ion X minus takes place simultaneously. That is breaking and making of the bond is takes place at a time. So the reactants on their way to produce the passes through the transition state where the COH bond is half formed and the CX bond is half broken. So SN2 reaction, it may be noted that in SN2 reaction the attack of the nucleophile takes place from the side opposite to that of the leaving group X. Therefore, such reaction produces with an inversion of configuration. So there is a mechanism, we'll get idea about the how there is attack of the nucleophile substrate takes place at the backside and at the inversion of configuration. So the OH minus will more electronegative base attack on a positive carbon atom, and which forms the transition state making of OH bond and breaking of the CX bond is takes place and form the product, and leaving of the X group is takes place. So the next reaction is SN1 reaction. On the other hand, SN1 reaction takes place in two steps. In the first step, the alkyl halide forms the carbonium ion by removal of the leaving group by the solvation. So what is the first step is that your substrate, that is tetrahedral shape of the structure. It is a slow step removal of the leaving group is takes place, that is halide. So there is a carbonium ion first of all forms. First step is formation of carbonium ion. It is a flat in shape. Then in the second step, the nucleophile attack on the electron deficient carbon from either side of the planar carbonium ion, that is from front side or back side also, so either side. The products are therefore racemic mixture. So there is a second step, you will get idea about the structural feature. The OH is attack from both of side on the carbonium ion, and it is a fast step and produces racemic mixture, because if it is attack at the front side, it will give first compound, at the back side it will give second compound. So these are the racemic mixtures formed during this step last. Then order of the reactivity all of this SN2 and SN1 reaction. So the order of reactivity of the primary, secondary, tertiary and alkyl halide to the towards the SN1 and SN2 reaction is given as, that is SN2 is considered, that is primary, secondary and tertiary. It is depending upon steric hindrance of the alkyl halide. So in case of SN2 reaction, reactivity is higher for primary than secondary than tertiary. It is opposite to SN1 reaction. First of all, higher in a tertiary, then secondary and primary. It is determined by the stability of the carbon, because stability is higher for tertiary than secondary and primary. Thus the preliminary alkyl halide normally undergoes the substitution by the SN2 mechanism, tertiary by the SN1 mechanism, and secondary by the both of SN2 and SN1 mechanism. So this is the steric effect or steric hindrance, because of the what type of the starting material substrate is used for this reaction. So OH is if attack on the carbon atom which contain the hydrogen attached to the hydrogen atom, so easily get attacked because there is no bulkiness to the hydrogen atom. But in case of the bulky group, alkyl group, it is present on that carbon atom, it will be difficult to attack on that. So there is a structure that will use that, how the steric hindrance CH3 group makes the attack on nucleophile OH difficult that, and it is denoted by the dotted circle which indicate the effect of the size of the group on this. So the nature of the leaving group also affects the rate of the SN1 and SN2 reaction, order of the displacement of X in a stronger nucleophile. In order to that, first is iodo, bromo, then chloro, and then finally chloro. That is which type of the group is also gives the idea about affection or affecting on the mechanism of this reaction. Then general reactions of alkyl halide is discussed under below, that is reduction, nucleophilic substitution, elimination reaction, reaction with metals. It will be noted that alkyl halides are the most valuable and versatile synthetic reagent, since almost all class of organic compounds can be prepared from them. Then first is reduction of the alkyl halide. Something related of the part of the SN1 and SN2 reaction mechanism, means difference between them, then kinetics of this reaction we will see afterwards. We will complete this point from that reaction. Then reduction of the alkyl halides on the reduction with the zinc, copper, and or coupled with alcohol, where with the zinc and hydrochloric acid gives alkane, that is ethyl bromide plus hydrogen, that is addition of hydrogen, that reduction reaction in the presence of zinc, copper, or in presence of alcohol or zinc with the HCl, it will, or hydrochloric acid, it will give ethane. Lithium aluminum hydride can also bring about the reduction of the alkyl halide to alkane. This alkyl halides may be reduced to the alkane with HN, that is iodo form, and red phosphorus at 150. So the reaction gives the alkane from this also. Then catalytic hydrolysis offers a better procedure for the reducing the alkyl halide to respective alkane, that is hydrolysis in the presence of lead alkane, it will use the alkane. Lead alkaline solution, it will give alkane. Then these are the points related with some of the reaction mechanism of SN1 and SN2, and last reaction, reduction reaction. So remaining part we will see afterwards in next video. So thank you once again for the listening this